Greetings, Pre-Calc students. It's time for our very first flipped curriculum lesson. And as you can see, it's lesson 1-1, Relations and Functions. And you can be writing down these notes, which I'll check over. Plus, I have a nice bonus feature for you toward the end of this little video as well. Anyway, first thing we want to point out is just some basic definitions, which you probably know quite a bit of already. And that is relations and functions. Anyway, a relation is a pairing of two sets. A relation is not like your crazy relatives over here in math, of course. It's a pairing of two sets. Usually these are in ordered pairs, but a relation could be represented as a graph or a table or something like that as well. Two key parts of a relation, which you've heard these words before: the domain, which we usually obviously think of as the x value. Here's a fancy name for that, the abscissa. The range is the other one, of course, that's the y value, and the fancy name for that is ordinate. I don't think we'll use these two terms very much at all. If you just remember that domain is x values and range is y values, that's really a key thing. Anyway, then a special type of relation is a function. So we could say that all functions are relations. And just a question to pose to you: do you think that all relations are functions? Something to consider. Anyway, what a function is: relation where each element of the domain is paired with exactly one element in the range. But an easier way, I think, to remember it is that each x value is different. Each x value is different. Next slide here, and take a look at these. Find the domain and range for a couple things here. First one here, I just have a set of ordered pairs, as you can see here. And do you think this is obviously a relation? Do you think that it is also a function? And the correct answer here is no. And why is this not a function? Well, we have a couple x values that are repeated, as you can see. We have a -2 here and a -2 here. That will disqualify it from being a function. But maybe getting back to just listing the domain and range, a lot of times we would just write it like that and say, here's the domain, and I would just write in what those x values are: -2, 4, -6, and 3, like that. That's my domain. My range then will be my y values, of course, which are 3, -1, 0, -4, and 7. Okay? So that's pretty basic. Once again, this is a relation, but it is not a function. Now, let's take a look at the graph down here, which I don't have anything graphed. But let's just say, for instance, that this was my particular function right here. This is going to be a fairly famous function that we'll see many times in this course. So there it is. I've just graphed it like there. We don't know what the specific equation is or ordered pairs or anything like that. So could I figure out the domain and range for this? Well, you might say, how am I going to do that? Aren't there many, many ordered pairs that I could pick from? And you would be right. So rather than try to list specific values or ordered pairs here, we're just going to describe this in more general terms. So the domain, remember, is the x values. And so we would say that my domain here is considered all real numbers. All real numbers. Because the x values could be anything. As you could see, we could have positives, negatives, not just integer nice numbers, but all kinds of values like that. Now, what about the range? Now, this one's slightly trickier. Can I say all real numbers? Well, notice in this case I cannot, because notice that there are no y values that are ever graphed underneath the axis like this. So what I'm going to say here for my range is that the y values have to be greater than or equal to 0. They have to be non-negative. So that's a good general way to describe a couple of this. All right, now we have something called function notation, which you've seen before. And typically, we see this as this f with the parentheses x. We read that as the f of x, not f times x or anything like that. And it means the value of the function f at x. So many times you might have heard something like, when you see that f of x, it really means the y value. That whole expression is the y value. So let's take a look at an example here. We have the f of x equals x squared plus 3x minus 4. And so this first example here, the f of 2 is how we read that. Well, all we have to do there is put 2 in place of x like this. And then evaluate it. So we have 2 squared is 4. Do your squaring first, of course. 3 times 2 is 6. So 4 plus 6 is 10. 10 minus 4 is 6. So we say the f of 2 is 6. That way, if we had an ordered pair and we were going to plot it, it would actually be the point 2, comma 6. All right? Now let's try one that's a little bit trickier here. And you can see that I have a little warning here, a binomial squaring. So let's just see what we get for this. Again, n minus 1 is in the parentheses, so I'm going to put n minus 1 in place of x. So it's going to look like this. And now I have to calculate this out. Now here's the warning right over here, which I mentioned. How do you square binomials? Well, you might recall this is going to be like my FOIL method. So I have to write it as n minus 1 times n minus 1 like that. And I'm going to go through this rather quickly for the sake of time. But out of all this, once I multiply this, I'm going to get n squared minus 2n plus 1. And then, of course, getting back to this part, I just have to distribute that. So that's going to be 3n minus 3. And then, of course, I have my minus 4 at the very end. So my final answer here looks like it'll end up to be n squared. I have negative 2n plus 3n, so that's plus 1n. And then with my numbers, I add up 1 minus 3 is negative 2. Negative 2 minus 4 is negative 6. So there's my final answer right there. A little bit tricky, but we'll practice on some more of these in your assignment, obviously. All right, last thing then, domain and range of something like this. Now, this is kind of a weird thing. You're going to probably want to get your calculators out, I think, so you can graph this on your calculator. But I'll just help you out a little bit for the sake of time here. It's going to look something like this. I made a little mistake there, I think, in graphing. Remember, on your calculator, when you graph this, a key thing is to put parentheses around that x minus 4. You remember that from your other math classes, I'm sure. Now, how do I express domain and range from this? Again, this is sort of like one other one that we did where we don't know a lot of specific ordered pairs. So can I think in general terms about sets of numbers? So my domain, can I say it's going to be all real numbers here? Yes, but I'm going to say all reals, but there's one x value that I don't want, and that is when x is equaling 4. And the reason that is, look in the denominator. If you might remember from your previous algebra days, we never want the denominator to be 0. And so that denominator, in order for it to not be 0, any number works except x cannot be 4. So we might say something like this, all reals except when x equals 4. And then if I think about my range here a little bit, well, is there anything that my range can't be? Well, it looks like there are going to be positives and negatives here. Remember, your range is your y values. So I think the only thing that the range would never equal would be 0. Notice that because we have this 3 in the numerator here, there's no way that that could ever be 0. So y is never going to be 0. We'll practice on some more of these too. Really the best way to analyze those is through a graph. And lastly here, just a little bit of trivia here. The first 2 people that tell me this tomorrow, has to be tomorrow during school, who is this guy and what did he do that was significant? Obviously it has something to do with the Olympics, which were held a few weeks ago. So see if you can figure out who this guy is. What did he do that was so significant? So good job. Thanks for watching. We'll see all you guys in class tomorrow.